Hello and welcome. So the article that we're going to be talking about is called it's about valve risks coronary artery occlusion. So in this article, they're creating this mock experiment about the heart. This is the left heart. Now this is the left ventricle. This is the aortic valve. These are the coronary arteries. This is the left atrium, and this is the mitral valve. So now you know usually the coronary perfusion happens in systole, I'm sorry, it happens in diastole, as you can see these two lines over here. In systole, the aortic valve opens, mitral valve closes, and in diastole, aortic valve closes, mitral valve opens. So basically, what this article is talking about. So what does valve in valve means? So usually you can have a surgical graft replacing the native aortic valve, but this sometimes the surgical valve it fails, it gets damaged, develops disease, whatever. So at that time, uh, one potential solution is the placement of a transcatheter aortic valve inside this surgical valve. So this is called valve in valve. But sometimes the problem is that the leaflets of the old failing this surgical valve, its leaflets can go up and block the coronary sinus. That creates a high mortality rate. So the researchers over here are simulating um, this valve-in-valve implantation, and they're testing different factors. For example, the valve, the coronary height, the coronary artery height, which is the distance over here, the distance between the aortic valve and the coronary sinus, and they're also testing implementing other physiologic features, like for example, they call it the stent to coronary sinus distance, which is the distance over here. But anyhow, so in this specific mock experiments, after implementing the valve-in-valve procedure, they did not, the researchers did not notice any occlusion on the coronary arteries, and they're basically using this setup to test for further future testing of this valve-in-valve implantation. Thank you so much.